I'm going to do a review day on 7, 4, 5, and 6. We'll just do lots of practice problems. And then Friday is a quiz, 7, 4 through 7, 6. Okay? Don't forget, if you're planning to retake the 7, 1 through 7, 3 quiz, you need to get that done. I put grades in this morning. So, yeah, so there it is. All right. So this section isn't too bad. And let me explain if my board will cooperate. Hello, board. Surprise, surprise. Okay. There's a radical idea. Come on. Okay, if I had this problem, does everybody recognize that what I could have written was this? The root is the same thing as raising it to the 1/2, the square root. Right? Do we remember that from early on in this chapter? To write the root as a fractional exponent, whatever the root is always the denominator. Okay, so my strategy has been to square both sides to solve it, right? Because by squaring it, I'm undoing the root, the square root. Well, when I square this, what do I do to what do I do to exponents when I raise it to an exponent? Multiply. And what's 2 times 1/2? 1. That's why the root disappears. Okay, so using that same idea, that's what we're doing in this this section is we're dealing with just fractional exponents. They're not written in roots anymore. In this section, they're fractional exponents. So as an example, let's do this one. 2x to the 3/2 minus 19 equals 35. Just like the last couple sections, your goal is to isolate the x term. The variable, not even the term, the variable, because anything multiplied by the variable I need to get rid of as well. So the first thing I'm going to do is add 19. With me still? Now, to isolate the x, I've got to divide both sides by 2. Okay. Now, to undo the 3/2, I just have to raise it to the reciprocal. Just like to undo the 1/2, I raised it to 2, which is the reciprocal of 1/2, right? So to undo this, I'm going to raise this to the 2/3, which means I have to raise this to the 2/3. 3/2 times 2/3 is just 1. So I have x on the left. Now, if it helps you, I can see this and I know exactly what the answer is. But if you're not there yet and it helps you, put it in a root. Okay? This means the cube root of 27 squared. What's the cube root of 27? 3. What times what is 27? 3. And 3 squared? So Jaron, that answer was right. It is 9, but it's not. Come on, 9. Well, I'm going to write a 9 there. X is 9. That's how you solve it. Okay, so you're using your strategies you learned in sections 1, 2, and 3 to understand what that rational exponent means, and then solving equations that way. Let's do one more. Um, 6x to the 3/2, maybe. Minus 141 equals 1917. Okay, so first I'm going to do what? Add 141. I was hoping I brought a calculator over, but I couldn't. add 141. So then I end up with 6x to the 3 halves is what? 2058. I kept hearing 15. Okay. Now I'm going to divide that by 6. 343. Raise it to the 2/3. So as a root, this means it's the cube root of 343 squared. So what times itself 3 times is 343? I'm going to say 7. 7 times 7 times 7 is what? There it is. This is why knowing your roots is good. We'll try and do our contest maybe next week on our cubes and fourths and fifths. Okay, so I have the cube root of 343 is 7, and 7 squared is 49, so my answer is 49. Make sense? Okay, so this section, there's no web work. They are classroom problems that are on Canvas. I don't remember how many there are. But you can go and it just says classroom problems on your assignments. Okay, so use the rest of the period either to start that or to finish 7.4, 7.5, whatever you need to do.